So they travel the speed of light, but they probably travel faster than the speed of light. They just call it light speed.
Why not just the speed of light?
Because it would take too long to go from system to system. So if that were the case, everywhere they'd show up, they're like, yeah, that the Star Destroyers blew that up 800 years ago. But thanks for stopping by. We really appreciate it. Thank you.
This is entirely correct. Even though the speed of light is the fastest speed there is, it is way too slow to be able to tell a story over a galactic scale. In fact, even going to the nearest star would take over 5 years of travel if you're only going at the speed of light. So, in order to tell a story that spans across the galaxy, writers must come up with some sort of faster-than-light drive that is capable of speeds thousands of times faster than the speed of light.
Yeah, but maybe it does take that long. It's just to them it doesn't.
No.
You mean the theory of relativity, that if you approach the speed of light, that time slows down for you?
If time slows down, why would time go faster? You mean it only slows down for the people going light speed?
It doesn't. But when somebody goes light speed, it doesn't speed up the world, the universe for everyone else, if that's what you're asking.
Well, I thought you'd be traveling at the speed of light.
This is the relative. This is where the relative falls into play here.
So you're moving at the speed of light, 1 light year in 1 year. Do you see that year if you're going light speed?
This is an excellent question, and it's these sorts of questions that actually show how interesting relativity can be. The short answer to this question is, unexpectedly, that Gavin's right. If you were travelling at the speed of light, you would not experience that year of travel. There are 2 main reasons for this. Firstly, from your point of view, everyone else in the universe will be frozen in time due to time dilation, because, from your point of view, they're the ones that are moving at the speed of light, and not you. Secondly, because of the length contraction that will occur with the rest of the universe, the distance between your starting point and your end point will actually be 0. Again, this is because, from your point of view, it's the rest of the universe that's moving at the speed of light. But how does this make sense from the point of view of the universe? Particularly from that planet that we're desperate to save from the Star Destroyers. Well, from their point of view, they would see your ship travelling towards them at the speed of light, but they would see you as being frozen in time. So this agrees with the idea that it would take no time at all from your point of view. But then this leads to the question, if you don't experience any time during your trip over 1 light year, what do you see from your point of view? To do this, we need to look at general relativity and what happens when you actually change your speed. It turns out that it's when you decelerate after reaching your destination that you experience the rest of the universe's time. So, you would see the year of your travel, but only in the last few moments as you decelerate from light speed.